Hello everyone. I am Dr. Devanan Girish Kumar, Associate Professor of Electrical and Electronics Engineering Department, BV Raj Institute of Technology, Narsapur. So today I'll talk about different drivetrain topologies of hybrid electric vehicles. So coming to the hybrid electric vehicle, so by the definition, this is not a pure electric vehicle. It is having combination of general IC engine and as well as EV. So the combination means it has two different driving machines. One machine is nothing but IC engine, another machine is nothing but electric motor. So then in order to drive IC engine, we need the external fuel like gas or petrol. And in order to drive an electric motor, we need the battery. So both are shown in this figure here. So the engine means it's an IC engine and it is driven by fuel, external fuel, and this is an electric motor and it is in a battery. So the major advantage of this HEV is nothing but it is a self-charging. So no external charges are required for this particular vehicle. The battery automatically gets charged whenever it is gets discharged. So then how it has happened, and in the models we will see everything. So coming to the major components, these are the major components. One is fuel tank, another one is engine, third one is electric motor, and fourth one is a battery. And also some control modules are there and some power converters are there in between the electric motor and battery. So then that we'll see in the next slides. Okay. So now here there are three types of vehicles like models are designed for HEVs. Then how in the sense the way of connecting the IC engine and electric motor to the driving differential is decided these three types. So these three types having a series parallel configurations. So in series configuration, the EV is having like the structure of EV is having like from here to here. So this entire model, the battery to the converter, electric motor to the differential is called as an EV, pure EV. And also instead of battery, sometimes we may use that flywheel or capacitors as energy storage systems. So that this combination will call as an EV. So usually if you have energy in the battery, that energy is fed to the converter and the converter will supply energy to the electric motor and the electric motor will run and it drive the differential. Okay. So this is the process. But as I told already in the previous slide, so it is not a like externally chargeable vehicle. So it is a self-charging inside the vehicle. Here what we are doing is we have another engine called IC engine. It is driven by the fuel here from the reservoir. And once the engine is driven, this output is mechanical energy, then that is connected to the electric generator. Then the output of generator is connected to the charger, and this charger will charge the battery pack as well as the flywheels. So means that here the IC engine only is used for driving, charging your batteries and driving the generator. It's not driving for a electric motor or the driving wheels. So the main drawback of this particular configuration is that nothing but instead of engine and the electric motor, we have another machine also here in this hybrid electric vehicle structure that is called generator, and this generator will weights more cost to this particular model. So let us see now another structure here. So the another model is the parallel construction of hybrid electric vehicles. Here the differential is connected to a shaft, and again one more differential is connected here, and this differential is connected to both engine shaft, this is IC engine shaft, as well as an electric motor. Here the battery is supplying energy to the converter, thereby the electric motor is driving and it is supporting your driving wheels of the EV. Also the reservoir supplies the energy. This energy is taken by the IC engine and it fires the particular fuels and produces mechanical energy, and that also supports the differential movement of the particular electric vehicles wheels. So then both the like engine and motor together driving the wheels here. So this is an efficient system. And also the charging, how the battery will take place here, because it's not a self-charging here also. So whenever the energy is there in the battery, the electric motor is driven by the battery so that uh, it drives the wheels. The if energy lost in the battery, so if it is completely discharged, then the engine solely drives the electric vehicle wheels together. Also, it drives the shaft of this particular electric motor, which is directly connected to the engine and electric motor, so that this motor also driven by this particular engine along with the driving wheels of EVs. So what happens here is now this electric motor will be acting as a electric generator because it is taking a like mechanical energy as an input, and it supplies energy back to the battery to charge the battery. So in this way, this parallel hybrid electric vehicle will work. Here any additional components like generators we are using, here electric motor itself is acting as a generator, and during the braking time and as well as during this completely discharge time, this batteries gets charged through this particular kinetic energy provided by the engine. So this combination of series and parallel hybrid electric vehicles, and here a big shaft is connected to the differential, like from IC engine to the electric motor. So here the reservoir initially connected to the engine, so that engine will driven, and it drives directly the driving wheels of EVs. And also along with the driving wheels, it also drives the electric generator here, and this generator will connected to a charger, and this charger will charge the battery, and the energy stored in the battery now again like fed to the converter. So this is power electronic converter, and this converter will supply energy to the electric motor, and electric motor is driven here. So once the electric motor is driven, then its shaft also connected to the driving wheels, so then the driving wheels also rotates along with the electric motor. So means that both IC engine and like electric motor both together is seriously connected here for the driving wheels, and they are connected in parallel for charging of battery. So hence it is falls into the category of series parallel hybrid electric vehicles. So these are the three topologies we have in the hybrid electric vehicles. In addition, we have one more like uh, another model of hybrid electric vehicle, the similar type of structure, but it also named as a plug-in hybrid electric vehicle. Earlier, what we discussed that those electric vehicles are not like externally chargeable, but here in plug-in hybrid electric vehicles, we have external charger to be connected in order to charge the battery. There is no self-charge mechanism in this particular hybrid electric vehicles. So that's all about the like driving topologies of particular hybrid electric vehicles. Thank you.